Hello and good afternoon, CTS110 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CompTIA Net Plus course, and this afternoon's video tutorial is going to be our solution set for worksheet number 11, where we continue to hone our skills on IPv4 subnetting. Specifically, we're going to be taking a look at subnetting Class B networks. So the activity opens up with a discussion about when you may want to use a very large number of hosts, but a very few number of subnets, and that's what the Class B address space is going to provide for us. We also talk here real quickly about a /30, right, when we've got basically a point-to-point connection between two routers, and so we would use a /30. But once we get into larger deployments, where you may need large numbers of hosts, that's where the Class B is going to come in handy. So here we have a scenario. This is going to kind of walk us through, before we dig deep in here to our own activities or our own challenges, what a Class B network would look like, right? So we've got the Class B network space here. So, and remember, Class Bs go from 128 up to 191 in that first octet range, because remember, that the first bit is going to be a 0, or I'm sorry, the first bit is going to be a 1, followed by all 7 zeros. 1, 2, 3, 4, 5, 6, and 7. So 128 up to 191. So actually 1, 0, and then we can have all of those bits filled in. So if you had 32, 16, 8, 4, 2, and 1, to 128, we would get 160, 176, 184, add the 4, a little hard to see there, add the 4, 188, 89, 90, 191, and that's our top end. So 130.200.0.0, so that's the subnet that we're given. The default mask, again, is a /16, right? So the first 16 bits in this Class B subnet are reserved for network bits, and this is our dotted decimal notation, 255.255.0.0. So now we want to figure out, we've got a medium-sized corporation, we have 3 large departments, so we need 3 subnets. Well, you're not going to get an odd number of subnets because we're dealing with powers of 2. So what we're going to have to do is we're going to have to overshoot 3, and that's okay, because as long as we meet our host requirement, it's okay if we have a few extra subnets lying around. So remember, the formula for the number of subnets is 2 to the n, where the n is equal to the number of borrowed bits. So we borrow the first host bit here, and 2 to the 1 gives us 2. We borrow the second host bit, so we have 2 to the 2 equals 4. Now, does that meet our requirement of 3 very large departments? It does. And in fact, take a look at how many host bits we have left over here. So we've got 8, 9, 10, 11, 12, 13, 14. So for hosts, we're going to end up with 2 to the 14 minus 2. And as you can see here, that's going to give us 16,382 host usable host IPs in that subnet, in each subnet. And we're going to end up with 4 subnets. So when we borrow those 2 bits right there, they have a value of 128 and 64, and our dotted decimal notation would be 255.255.192.0. Now remember, in order to come up with the subnet IDs so that we can sort out where each network boundary will be, in terms of boundary, we're talking about the subnet ID and the broadcast address, if we can get to the block size, right, that is going to be the key. And so that is this step right here. Highlight the rightmost one in the binary bit mask. And so it's that value right there. That is your block size. And again, remember, we've said as soon as you get the block size, it's game over. Now, recall that Class B IPs, right? We're talking about /16. So that third octet is the interesting octet. When we were talking about Class C addresses, it was always the fourth octet that was the interesting octet. And by interesting, we mean we were borrowing bits out of that octet. So now we're interested in the third octet, which is the one we're going to be manipulating here. So again, if it was 130.200.0.0, we simply increase by the block size of 64 until we get to 255. So there are the four subnets we knew we were going to have because we had sorted that out early on. And again, we start at 0, add the block size, add the block size, add the block size. And so if I were to ask you what would be the third usable IP in the third subnet for 130.200.128.0, you would easily be able to figure that out. So let's go ahead now and move on here. We've seen sort of an example. Let's take a look at the first scenario that we're going to be working with here. So, and they've got 7 subnet. Boy, this is going to get a little large here. Let me see if I can shrink it down just a skosh to squeeze everything onto one screen. There we go. That'll do it. Okay. All right. So your corporation was assigned a Class B IP address and has 7, and there's our key. So we should immediately know that, yep, we're going to go with 8 subnets. So 2 raised to the what is 8? To raise to which power is 8? Exactly. 2 to the 3 is going to give us 8. So create the configuration. So here's our subnet, right, or the Class B IP address space that we're being given, I should say. Now, what is the Class B default mask in binary? 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot, and that's it, /16. So the next 16 bits, 2, 3, 4, is that right? 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. So that is the binary representation of the /16, which is the default mask. So what's the default mask in dotted decimal? 255.255.0.0. And I've got the spacing here, just trying to line it up with what's above in binary. So what is my new subnet mask? Well, the question then becomes, we've got to borrow some bits, so how is that going to work? Well, remember, the number of borrowed bits is going to tell us how many subnets we have. We know we need 8 subnets because we can't get to 7, so we have to have at least one more than that. So 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. And what other critical value have we just locked in on here? Exactly, 32, and that is my block size. So literally, at this point, I could stop and sort out every value that's going to be in these subnet ID fields. But let's work through here, and we'll get to that in just a second. So hopefully you see that 32 is our block size. That is the rightmost value in the bit position of the last bit we've borrowed for subnetting. So what is my new subnet mask? Well, remember, the new subnet mask would be 255.255. We've borrowed 128.64, the bit positions in 32, so we get 224.0. So the new subnet mask is 255.255.224.0. That is a /19 because we borrowed 3 bits from our original default mask of /16. And so again, the new mask is /19. Highlight the rightmost 1 in the binary mask. It is right there. We highlighted it in green. And that gives us the value of 32. And that is the block size. So the new subnet mask in dotted decimal, that should be binary. So we'll reverse these guys. So we'll do the binary here. It's going to be 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3. And remember, we're reversing these guys here. 0.1234567 All right, so number of subnets, we know that it's 8. Now, number of possible hosts in each subnet. Well, how many host bits remain here? We've got 1, 2, 3, 4, 5, and then 8. So we've got 2 to the 13 minus 2. Well, if 2 to the 14 is 16,382, half of that is going to be 2 to the 13. So this is going to be 8190. What is that going to be? Let's divide by 2 here. So it should be 8, 1, carry the 1, 9, 1. 81, that's not right. 8191. 34, sorry, that's where I was wrong. It's 16,384. So 8192. So 8192 minus 2 is, minus 2 is equal to 8190. So we're going to have 8,190 possible host addresses per each of these 8 subnets. So let's go ahead now and fill our values in here. So we've got our block size, it's 32. So for the third octet, we're going to just basically bump it up by 32. 155.220.32.0.64, 64.0.96.0 .128.0 .160.0 .192.0 .224.0. Now that's the 7 we've been asked for, but 1, 2, 3, 4, 5, 6, 7, 8. Good. So that's the 7 we've been asked for, and we've got this additional guy right here who is going to be used at a later date. So now it becomes very easy to figure out our range. The broadcast address would be 1 less than the next subnet ID. So 155.220.31. .63. Sorry about that. .63. Or no, that's right. I had that right. I'm looking backwards here. .31.255. Because after 31.255 comes 32.0. So .64.0 is the third subnet. So then the broadcast address would be 155.220.63.255. And then it's going to be .95.255, .127.255, .159.255, .191.255, and again, it's the same first 2 octets all the way down. .223.255, and then finally .255.255. And so those are the broadcast IP addresses for each of these 8 subnets listed here, right? So the valid host IPs, let's put the range here. So it's going to be 155.220.0.1 all the way to 155.20 or 220, sorry, .220 .31.254. Again, it's just going to fall within the range that we have here. So for this subnet here, it would be 155.220.32.1 all the way to, and I'm just going to do the last 2 octets because that's what's going to be changing, 2.63.254. And then we've got .64.1 to .95.254. We've got .96.1 to .127.254. We've got .128.1 to .159.254. So you see the pattern, right? We go +1 for the values that we have here for the subnet IDs, and then we go -1 because we're one less than the broadcast address. So .160.1 to .191.254, and in this range right here, you're going to get your 8,190 usable IPs. They're all in that range right there. So then we've got .192, add 1, .1, and then one less than what we have over here, 223.254, and then finally .224.1 to .255.254. All right, so that takes care of this corporation's need. We got 8 subnets. Each subnet will contain 8,190 usable host addresses, and we had an extra subnet left over for future growth. All right, so that takes care of this portion of the worksheet. Let's clear the screen here, and then let's roll down where we're going to be taking a look here at another opportunity. And let's see, I'll leave it right there where we can read the top. So we've got 13 subnets. So that's what we have up here, 13 large departments. So what is our subnetting scheme going to be if that is the Class B IP address that we've been given? And we've been told that we can go ahead and carve that up any way we want. All right, well, let's start out with a default mask in binary. /16, or I'm sorry, it's a 16, right? So 1, 2, 3, 4, 5, 6, 7, 8, /16. So the first 16 bits are all going to be network bits. 2, 3, 4, is that right? Yep. And then we've got our host bits here. 3, 4, is that 1, 2, 3, 4, 5, 6, 7, 8? Dot 1, 2, 3, 4, 5, 6, 7, 8. So that is our default mask in binary. The default mask in decimal, we know for a Class B is 255.255.0.0. And then our new subnet mask in binary, I'll get this right this time. So in binary, we know we're going to need 13, and I'll fill this in here, 13 subnets, right? So we know we can't get 13 exactly, but that's okay. What's the closest we can get? Well, 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is going to put me at 16. And that's okay if we end up with 3 extra subnets. The requirement is we need 13 large departments. And there's no additional information here in terms of how many usable IPs each department needs to have, but you can count on it being right around 4094 if my math is working for me here. So the new subnet mask in binary. So if it's 2 to the 4, how many bits, how many host bits do I need to borrow and convert into network bits? Exactly, we need to borrow 4. 1, 2, 3, 4. So we're going to have 12 host bits left after I borrow these 4 network bits, right? So what is the new mask in binary? In binary, we're going to have 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot our 4 borrowed bits, 1, 2, 3, 4, followed by, and let me shift these into 1, 2, 3, 4 dot 3, 4, 5, 6, 7, 8. So the new subnet mask CIDR is going to be a /20, right? So highlight the rightmost one in the binary mask, because again, this is the golden ticket right here. This is going to give me the block size value, and it's 128, 64, 32. What do we have? We've got 16, right? 128, 64, 32, 16. So we know that the block size is going to be 16. So I'll put down 16 here, right? So that's the key, because that is going to help us come up with all of the subnets we need. So new subnet mask in decimal would be 255.255.128 plus 64 is 192, plus 32 is 224, plus 16 is 240.0. So that's my new subnet mask in dotted decimal. So question 1, number of subnets we ended up with. We ended up with 16. You can see here they're only going to ask us to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I believe the sheet may continue on a little bit below us there. So number of possible hosts in each subnet. Well, it's 2 to the 12, and that was a terrible 12, minus 2. Well, 2 to the 12 is 4096 minus 2 is going to give us 4094. So that's a pretty decent sized subnet where you have 4,094 hosts in that subnet. Remember, a subnet would be a VLAN, would be a broadcast domain, right? So pretty big broadcast domain right there. Okay, let's work through here, focusing on that third octet, right? So it's going to be .16.0, .32.0, .48.0, .64.0, .80.0, .96.0, .112.0, .128.0, .144.0, and so on and so. And then it's just going to continue to go. You just keep incrementing that third octet by 16. If I were to continue on, we'd have .160.0, .176.0, and we'll play this all the way out. What do we got here? 192. .192.0, .208. Sorry about that. .208.0, .224.0, .240.0, and that's it. Because if I added 16, we'd have .256.0. We know that we can't have 256. So we end right here. That's our last subnet. So what do we have? 1, 2, 3, 4, 5, 6. Added to the 10 we already have over here. And there are our 16 subnets, of which we're going to use 13. So let's do a couple of these here. So valid host IPs. Well, let's make it easy. Let's box it in here. The broadcast address is going to be 137.20.15.255, right? Because the next bump is going to be 16.0, which would be our next subnet ID. So then for .16.0, it's going to be 137.20.31.255. You see how it's just one less than the subnet ID. So then we've got 137.20.63.255. In fact, you may notice a pattern developing here. That each of these, I'm sorry, I bumped up to the wrong one. That would have been .47. I went backwards again here. So let's see, we've got 15 was right because it was 16 was next, and then 32, it wasn't 31. It should have been 47. My apologies there. Should have been 47. And then it would have been 63. So then 137.20 and again, let me make sure I get this right. So from 80, it's going to be .79.255. And then 96 would be 95.255. And then it's going to be 111.255. And then it's going to be 127.255. And then it's going to be 143. And I'm off again. Did I bump off again? No, that's right, 95. So for that, it would be for 96. Yeah, I did. I apologize here. I keep looking left and right, and I am completely hosing this here. So this would be 63. It wouldn't be 63 for 48. So this is pretty terrible right here. So let's do this. Let me slow down a little bit. So I'm going to put the third octet field here. So for the first subnet, it would be 15.255. For the .16 subnet, the broadcast would be .31.255. For the 32, it's going to be .47, and that's where I messed up because I put 63. You can see it in there. For the 64 subnet, I'm sorry, for the 48 subnet, I almost did it again, it's going to be .63. And then for the 64 subnet, it's going to be .79. For the 80 subnet, it's going to be .95. And again, this is .255 at the end of each of these. For the 96 subnet, it would be .111. For the 112 subnet, it's going to be .127. For the .128 subnet, it's going to be .143. For the 144 subnet, it's going to be .159, because again, we pick up here at 160 for our next. Okay, getting a little rusty here. I'm looking left and right and not keeping my columns lined up. Okay, so valid host IPs. I'll do a couple of these and then you can go, you'll have the rest. So 137.20.0.1 is my first usable. My last usable is .15.254, right? Because this would be .15.255 for the broadcast. So I'm going to do the last two octets as 137.20 remains constant throughout. So .16.1, .32.1, .48.1, .64.1, .80.1, .96.1, .112.1, .128.1, and .144.1. So the last usable is going to be one short of our broadcast address over here, and this is kind of turned into a dumpster fire, but hopefully you're staying with me. This is our third octet here, right? And then we've got, I put 255, that's the fourth octet. So again, for the .16.0 subnet, the broadcast address is .31.255, so my last IP is 31.254. And then it's .47.254, and then it's .63.254, and then we've got .79.254, .95.254, and you should be noticing a pattern here is what is it incrementing by here? Exactly, it's bumping up by 16 each time. So .111, .254, .127.254, .143.254, and finally .159.254. So again, I apologize about the train wreck here in the third octet as I crisscross some of the values as I was moving from left to right, but we've got it sorted out here. And so that's exactly what it would look like. And so then this takes care of the final company workup here where we needed 13 large subnets, and they are extremely large. Each subnet is going to be able to hold 4,094 usable host IPs. All right, well, this is going to wrap up the activity here. I don't know if it went further down. It did not. That's going to wrap up our activity here for Worksheet 11. Hopefully this has cleared up any confusion you might have had when working through the Class B subnetting. Remember, when we're talking about Class B subnetting, it's all about starting in that third octet and then working our way through. All right, guys, enjoy the rest of your weekend, and I will see you on Tuesday evening.